So now we see the different methods of separation of the mixtures. So first we see are the solid-solid mixtures. So in the solid-solid mixtures, what we discussed in the last video was the first one was sublimation. Sublimation is going to be the method to be used when you have one normal substance, one element is normal element, so non-sublimable. So one is sublimable plus non-sublimable. So if the mixture is of a nature that one of the element is sublimable and other is non-sublimable, you can use the method of sublimation. So we have taken the example of ammonium chloride and sodium chloride. Both are white color powders. When they are going to be mixed together, it is not going to give you any kind of identification that which is there. So in no way you can separate it out just normally. So what we'll do is that we will take a particular dish over here. In that dish, we are going to take this powder, which will be a combination of mixture of these two. And on this, you are going to put a funnel. So you are going to put an inverted funnel, and to that inverted funnel, you are going to put a cotton over here so that the fumes are not allowed to go outside the funnel. So you are just allowing the fumes what are going to come out on heating. So we are going to heat this thing over here. So I'm going to heat it over here, and when you heat it, what will happen? This thing, both are going to get heated. So but this one heating is going to turn directly into gas, right? So on heating, this is going to turn into gas, and the vapors of this thing are going to be formed, and since they cannot go out over here, they will be settling down on the periphery of this particular funnel. So the complete funnel will have that particular substance of NH4Cl being layered on the sides or the walls of the funnel. So on the walls of the funnel, you will get this particular ammonium chloride over here. So this can be easily then separated out. You can just take that funnel and just put your finger and put it like this. So yeah, that will be how you are able to get the sublimable substance. And of course, what will remain in the dish will be NaCl. So here in this way, you are able to separate out very easily NH4Cl and NaCl, because what is the principle we are used? Sublimation. That is principle that one of the element which was there on the compound is a sublimable substance. Hence we were able to use this particular method. The next method is magnetic separation. So the next is magnetic separation. So in a magnetic separation, the main thing what we require is that we need to have one substance magnetic and the other substance not magnetic. So if it is like iron, okay, I'll write it, iron and sulfur. So sulfur and iron, when they are mixed together, you know that iron and sulfur. So now we have just a simple thing, you put it in a dish and put this particular powder of iron and sulfur together. Now we take a magnet over here, so now it's out like this. Anyway, you can take south node also, it's not just a magnet, it's a simple magnet. So this magnet we are going to take, and as soon as you put inside, all the iron filings are going to stick to this particular area of the magnet. So the magnet is going to attract the iron pieces from the sulfur powder, from the iron sulfur powder, and what is going to remain in the dish will be sulfur, and complete iron is separated out from the mixture. So accordingly, you are using magnetic separation when you want to separate two solids wherein one of the substance is magnetic in nature and the other is not magnetic in nature. So the principle of separation is magnetic, one magnetic material, other non-magnetic material. The third one is when you have got solvent extraction. So it is the process in which one of the element is soluble and other is not soluble. So that is the third one is solvent extraction. So the example over here is taken as sulfur plus charcoal. Okay, you are going to take sulfur and charcoal. Now what I'm going to do is, to this I'm going to add carbon disulfide. This is a liquid, this is a solvent. Okay, if you put water in it, both of them are not going to get dissolved, so you cannot use water over here, but you are going to take one particular kind of a solvent. Solvent are those particular liquids which can dissolve a particular material. So here we are going to take solvent as carbon disulfide. Now when we take carbon disulfide, sulfur is going to dissolve in carbon disulfide, but charcoal will not dissolve in carbon disulfide. So what you can do is just take a container or a beaker containing this carbon disulfide. So this particular thing is carbon disulfide. And this carbon disulfide, you are adding this powder of this thing. So you're adding this powder over here, and then you stir it. Okay, you stir it. So you take a stirrer and you stir it. When you stir it, you will find that the complete carbon disulfide will dissolve the sulfur, and there will be still the black colored powder left out behind. You take a filter paper. Okay, filter paper le lo, or then you filter that thing. When you filter that thing, what will happen? The complete carbon, that is charcoal, is going to be there in the filter. So the filter will be completely filled with carbon, and what you get will be the solution of sulfur. So when you do the evaporation, you can get the, on evaporating this particular carbon disulfide, you get sulfur, and over here, you're in the funnel, you are getting the carbon. So you can see that add a mixture A and B to a beaker containing carbon disulfide. Stir till the soluble component dissolves. Filter the component of the beaker, and soluble component A is obtained on slow evaporation of the filtered solution, and insoluble component B is remaining in the filter paper. So in the filter paper, you get the charcoal, and the liquid part will contain, the filtered part, the liquid part will contain the carbon disulfide with sulfur. To get the sulfur, you are going to evaporate the carbon disulfide. So, in evaporating the carbon disulfide, what is going to retain is the sulfur. So, that is the method of solvent extraction. The fourth method which is there is the method called as fractional crystallization. It is fractional crystallization. Now, you must have seen crystallization many times in your house itself, but you never knew that it was crystallization. I'll give you examples. Have it ever happened in your house that you had got jalebi in the morning for breakfast or lunch, okay? Like गाठिया जलेबी लेके आए हैं सुबह सुबह, and वो सुबह finished नहीं हुआ था, and the evening when you open that box which contained that jalebi, you will find that that jalebi will be having white small dots on it. What is that? That is nothing but the excess of sugar which was there in the jalebi, which got crystallized, and that is nothing but the crystallization of the solids. So when you have got any kind of a saturated solution, so when the water evaporates from there, what is going to happen is that particular solute which was there is going to crystalline. Now, so this is the process of crystallization. Here what we are learning is fractional crystallization. That means we are having two substances. We are going to have two elements or substances which are going to be mixed together, and both of them have got a difference in their solubility in substances. So in such a case, what will happen is one of them, so what you example you have taken is KNO3, that is potassium nitrate. It's potassium nitrate, and other is KClO, which is nothing but O3, which is nothing but potassium chlorate. So potassium nitrate and potassium chlorate is there, wherein potassium nitrate is more soluble and this is less soluble. So you will find that you are going to take a beaker put this mixture into the beaker and put some solvent into it. So this will be completely here dissolved inside, right? Both are going to get dissolved to an extent that this becomes a saturated solution. So now what you do is that you add A and B to the beaker of water and heat to obtain a hot saturated solution. So you're going to have a hot saturated solution. That means you cannot add any further salt into it. So that is how it is forming a saturated solution. Now you cool the hot saturated solution, and when crystallize, and when you are going to cool it, what will happen is that on the surface of that particular liquid, you will find that this one, which was less soluble, will start forming crystals and form a layer on top of the liquid. So on top of the liquid, the excess amount of this particular part, that means this particular part which is not less soluble, that is, this is more soluble, so it is going to dissolve completely, whereas this is less soluble, so this is not allowing this to enter there much deeper, means it is not allowing it to retain over there, and hence it will float out or come out in the form of crystals. So that crystals can be easily obtained by just taking a filter. So filter paper में वो pour कर दो, filter paper के ऊपर you will get is potassium chlorate, and the liquid will be the solution of potassium nitrate. On evaporating the water, you are going to get potassium nitrate as the crystal form on either evaporation or heating it over here. So you get less soluble solid A is filtered out from the hot saturated solution, crystallized from hot water and dried. And whereas the solid B is obtained from the filtrate by heating the filtrate followed by cooling, the crystals of more soluble solid crystallize out. So again, when you heat it much more and remove the solvent much more, so when you evaporate the solvent, then the solid which is going to be there inside is going to crystallize out, and you are going to finally get the potassium chlorate also, potassium nitrate also. So this was the 4 forms of separation of solid to solid mixtures. The first one was of the sublimation, second magnetic separation, third is solvent extraction, and fourth is fractional crystallization. We now move ahead for the next part, that is solid liquid mixtures. So now we have a solid and a liquid, and both are mixed together, and we need to separate them out. So it is solid, liquid mixture. So when you take a solid liquid mixture, we have got the example over here as calcium carbonate and the other one is water. So we have got calcium carbonate and water over here. Now this is the, the type over here was, it is filtration. The type is filtration. This is the kind of a mixture when the solute, that is the one which is going to be dissolved in water, is insoluble in water, means it is not going to get dissolved in water at all. So that is why the example of calcium carbonate is taken. Calcium carbonate does not dissolve in water. So that is the reason what will happen is that if you keep on stirring, it will still remain inside over there as particles. They are not going to get into the liquid and they not dissolve inside. So accordingly, then what we do is that we just take a simple funnel. We take a funnel, funnel के अंदर एक paper रखेंगे, that is a filter paper. We'll keep a filter paper and put that funnel into a beaker and then pour the liquid over here. You will find that all the calcium carbonate will be retained here and the water is going to be separated out. So this is a simple thing, the way you also separate out dust from water, that is just take a cloth and put the water so the dust particles are remaining on top of it. So it is simple filtration. So place a wet folded filter paper in a funnel, clamp about the beaker, pour the mixture A and B carefully. Insoluble part A remains in the filter paper, it is dried and recovered, and the liquid component B remains behind in the lower beaker. The next one is sedimentation, decantation. So here still this particular thing was such that if I keep it for a longer period of time also, it will not settle down. It will still remain inside. Okay. So when it is not settling down, at that time I need filtration. But many things are so easy that the moment I keep it for some few hours, the whole solid part is going to settle down. So the example over here is for sedimentation. Is sand plus water. So if you take some water and sand and mix them together, you will find that okay, initially it is like a homogeneous mixture, but after a few minutes, you will find that all the sand would have settled down completely. So settling down of the dust particles of the sand completely down into the lower part of the beaker is called as sedimentation. So what you do over here is that once the sedimentation takes place, you slowly take the beaker and pour out the liquid part without affecting the sedimented part. So sedimented part remains inside, stuck to the lower part of that particular beaker, and you are taking out the water from top of it. Hence, sand and water can be separated out by sedimentation, and the removal of the water from that particular beaker is called as decantation. It is decantation. So it is sedimentation and decantation takes place. So sedimentation होने के बाद में the process what you do is called as decantation. So that's why they are given over here that processes mixture A and B in a beaker. Take the mixture A and B in a beaker. Keep the content aside for a while. Insoluble solid A settles down. Liquid B component decanted, that is poured out. Okay, decanted or poured out into a beaker. So that is how sedimentation and decantation is done for those substances which are insoluble and which settle down, means they are heavier particles and hence they settle down inside the solid, inside the liquid. The next one is the example of evaporation. So when it is such that the substance which is dissolved in the water, in the liquid, is a soluble substance. So that's why we are having a process which is evaporation. So the example over here would be simple: sodium chloride and water plus water. So sodium chloride and water, that is salt water. Sodium chloride is nothing but the common salt what we have in our house. Sodium chloride and water, when you are mixed together, and then if you want to separate out the salt from the water, simple thing what you do is you are going to take it in a container and put this particular liquid inside, start heating the liquid, the water is going to get evaporated out, and what is going to remain here will be the salt particles. So salt will be separated out from this thing by the evaporation of the water. That is exactly how the salt is prepared by the evaporation of the seawater, and that you will see on in the salt pans. So salt pans, if you have seen when you are traveling out of Mumbai, in many places you will find white colored areas which are called salt pans, where they take the seawater and spread it across, so the water evaporates and what is going to remain there will be salt. So this is how they extract the salt from the sea. So that is what they do over here, that place the mixture A and B in an evaporating dish and heat carefully on a sand bath. The flame is adjusted to prevent the solid left behind in the dish from spurting out. So you're not allowing it to boil it out. So that's why you are keeping it in a way that the flame is so adjusted that it doesn't start boiling. Okay, and in the evaporating dish is you get recovered. What you can recover in the evaporating dish will be the salt, and the liquid component is lost as water vapor. Now suppose it is so that we want the liquid part also from that particular thing, then we can use a method which is called as distillation. So the method in which you can separate out the liquid from the solid liquid mixture, so it is called as distillation. So the example over here they are given is lead nitrate and water. Okay, you have taken lead nitrate and water, or you can take even salt and impure water, and like salt water and water also. So it could be anything. Lead nitrate is just an example they given you. You can simply take over here is seawater. Okay, let's take just seawater, and you are converting the seawater. What you want from the seawater is pure water. So you want pure water. So what you have is there is a flask over here. This flask contains the seawater, and to the flask connected is a tube which is connected to a condenser. So there will be something over here which is called as a condenser, and there will be a tube passing through this way, and there will be the collection point in a beaker. So what happens is you start heating this beaker. When you start heating the beaker, the water from the salt solution is going to start evaporating, boiling, so vapors will be formed, and the vapors will start coming inside this particular tube. Right, so the complete tube will get filled with the vapors of water. So what we do is that in this particular kind of the arrangement that's called a condenser, you are going to pass over here cold water. We are going to pass cold water inside over here. So the cold water, what we will do is that it will cool this particular water vapor. So on water vapor, when it gets cooled, you will get droplets of water from this particular condenser. So the condenser is that particular part which is going to condense, or which is going to do condensation, or which is going to convert the gaseous water vapor to liquid water. So this method in which the water or the seawater may say water nikala. Okay, what we got was the water from the seawater and not the salt. So salt is over here only. So you have the mixture of an impure water, and liquid component will be water. Add the mixture of A and B in the flask distillation apparatus. The mixed flask is then carefully heated as shown, and the soluble solid A remains in the flask after evaporation. So it is going to remain in the flask only, whereas the liquid component collected in the receiver after the condensation. So after the condensation over here, so there will be a water inlet from here and outlet from here. So the continuous flow of water will be there, inlet, outlet. Okay. So continuously there will be flow of cold water so that the water condenses. So this is how you are getting the solid liquid kind of mixtures being separated. So we saw the 4 different kinds of methods by which the solid liquid mixtures are separated. One was filtration, second was sedimentation along with decantation, the third being evaporation, and the fourth being distillation. So these were the 4 kinds of the solid to liquid mixtures. The next what we see is the liquid mixture. So now when we take the liquid mixtures, as I told you, the liquid mixtures are very easy because there are only 2 ways. One is the method in which the 2 liquids are not miscible, means they are not going to get mixed with each other. So if they're not going to get mixed with each other, it becomes very easy. Like what they do is, like for example, they are given oil plus water. So if it is oil plus water, what you are going to use is separating funnel. We are going to use a separating funnel. So separating funnel is just like a pot over here. It will be just a kind of a pot like this, having a tap over here. This will be a tap. Where there is a tap over here, and so the water is going to come out from here. So this is the kind of when you open the tap, the water start going, or the liquid is going to start flowing downwards. So if you have got a liquid, so if you put the over here, you will find that the water will be up to this point and the oil will be up to here. So this is oil and this is water. Simple. So when you pour them together, you will find that both will easily get separated out. You can easily make out that okay, ye itna hai aur ye itna hai. Simple thing what you need to do is take a flask over here and open the tap. Let this water come down till the point that the water is reached this particular point. So जब oil यहाँ तक आ जाएगा तो water सब निकल गया. So it is just like removing the water from the below part. So always the heavier kind of a liquid will be settling down and the lighter one will be floating on the top. So the immiscible liquids are separated out. So pour A and B from the top of a separating funnel clamped. Allow the mixture to settle down, stand on the funnel for some time till the layer heavier below and the lighter will be above separate out. Lighter liquid A remains in the separating funnel. So this oil will remain in the separating funnel. Water is removed from heavier metal is collected from the flask by opening the tank. So that's very simple method. The next one is fractional crystallization. Now in fractional crystallization, it is similar to distillation, but over here the difference is that you are having two liquids and both these liquids are such that they have got different boiling points. If one is going to boil at 80 degrees Celsius, the other is going to boil at 110 degrees Celsius. So that is exactly what we are going to use as a fundamental principle to separate them. So what we have is a beaker. So this is called as fractional distillation. So in a fractional distillation, what we have is something like methyl alcohol. It's methyl alcohol plus water. So when methyl alcohol and water are added, combined together, you will find that you cannot make out the difference between the two. So they are immiscible, miscible liquids. They are miscible liquids, so they get mixed up or completely together. So you don't come to know that whether there is any kind of a thing added to it or not. So that's how they get mixed together. But methyl alcohol will get heated up very soon, that at around 80 degrees, it is going to get heated up and turn into vapors, where this is going to be done at 100 degrees Celsius. So now what we are doing is we are taking a container which will contain this both A and B, and we are going to heat it. Of course, before we heat it, we are going to pick the apparatus. So the apparatus will be having something over here as called as the distillating column. So here there will be something like this. Okay, and over here then will be the condensing part, cold water outlet, and this will be the drops coming into the beaker. So what here happens is when you start heating it, methyl alcohol will get converted into water vapor, into the vapors of methyl alcohol very easily, because it is 80 degrees itself, it is going to form into vapors. So that is going to come over here. Now as soon as it comes over here, what will happen? The water will also be there, it will be part. There will be part of water which also will be coming over here, but as it comes over here, it will cool down. So water cools down and it is going to fall back into the liquid. Whereas because this is already reached 80 degrees, so the methyl alcohol is already reached its boiling point, so that doesn't get cooled down so fast, so it goes further and comes over here. You are now cooling this particular vapors of methyl alcohol, and what you get over here will be droplets of methyl alcohol in the container. Got it? So you are heating both of them. One of them is getting completely converted into gas, other one is partly gas and partly water. So because it is partly water, so what will happen? The water part which is going upwards will not, as soon as it comes to this area, it is slightly cooler here. So because it is cooler here, so it is not, because it is not reached 100 degrees Celsius, that is its boiling point, so it will condense and fall down. Whereas the 80 degree one, that is methyl alcohol, is completely full energy, full kinetic energy उसके पास के ऊपर जाएगा, और इधर जाने के बाद में you are cooling it by the cooling water and condensing it to give you the required methyl alcohol. So this is nothing but fractional distillation. Now we see two small things over here which is called as the chromatography and centrifugation. So these are for complex kinds of mixtures that you use this particular kind of a method. Now chromatography is going to be used to find out that what, so see normally what happens is that a particular ink is being made by combination. We very well know that the three main colors are red, yellow. Sorry, it's RYB. Yeah. Okay, so it is red, blue, and yellow. So these three colors form the different colors. So the primary colors जो है उसी से you are making the different colors. So when you want to identify that which are the different colors used to make a particular color, they use this process called as chromatography. So the next process is called as chromatography. In this case, what you do is we take a piece of paper. This is a particular chromatography paper, and to this paper, on one particular line, we are going to put a particular ink drop. So this is going to be the drop of the ink. Okay. So on ink spot is there. So this is basically, the paper is a filter paper. It's a normal filter paper. You cannot, there's nothing different in a filter paper and a chromatography paper. Just a filter paper. Filter paper has a tendency to absorb water. So that's why it will be this way. And then you are going to take a beaker and take solvent inside. So you are going to place this particular chromatography paper, that's paper dipped inside this solvent till the point that the ink spot reaches the solution. Okay, so ink spot reaches the level of the water is what you see. After some few minutes, you will find that the ink spots, so the solvent flows over the ink spot, and the solid constituents of the dye, that means the green color, the yellow color, that is going to get separated out, and you are going to find blocks over here. There will be dots over here, and like dots of A, B, C, D, A, B, C, D, ऐसे करके आ जाएंगे. So जो that is nothing but telling you that this color was made up of 1, 2, 3, and 4 different kinds of dyes. So these were the dyes which were used to form this color. So this is an thing which you normally do for finding out what are the colors used in a particular dye. So that's called as chromatography. The next one is when you have got to separate a heavier part from a lighter part. So when a mixture is such that one is a denser part and other one is a less denser part, then you use something which is called as centrifugation. So in case of centrifugation, what you do is, like in case of separating the milk from the cream. So when you want to separate the milk from the cream, you are going to use the centrifugation, wherein there are just test tubes which are connected over there. That test tubes are filled with that thing, and then the test tubes are made to revolve. You know, they are just going to rotate in a mixture, and such that it just goes round and round and round and round, so that the heavier part is moved backwards and the lighter part comes on the top part. So the more denser part of the mixture migrates away from the axis, so it is going to go into the axis. So what is going to happen is, if this particular test tube was there, which was filled with so let's say milk, it was filled with milk, and when you centrifugate it, what will happen? The heavier part will be over here and the lighter part will be over here. So that is how the heavier and the lighter part will get separated when they are moved round and round and round and round and round in a mixture, in a particular churner, and on churning it, the heavier part will be, or the denser part will be left on the bottom and the heavier part will come on the top. So that's exactly, you must also see this thing, when you take a milk and you are going to take some churner and you churn that milk, what is going to happen? The complete the foam comes on top. What is the foam? Foam is nothing but the lighter part and the milk is at the bottom. So that is how you are getting the foam of the, when you take the coffee and all, when you pour it from a top, so the foam is coming up. Why is that so? Because it is the lighter part being upper and the lower, the heavier part being down. So this way involves centrifugation force for separation. So a revolving object exerts a force away from the center of the rotation called the centrifugal force. More denser component of mixture migrates away from the axis of the centrifuge, and less dense component of the mixture migrates towards the axis of the centrifuge. So that was about the centrifugation. I forgot to read about the chromatography part. So it is separation of solid constituents of A, B, C and D, which are different dyes in liquid constituents of an ink. So chromatography is based on the difference of absorption of the adsorption. You know, absorption. The adsorption is different than absorption. Our solid constituent of a dye on a surface of an adsorbent medium, for example, a filter paper. So filter paper has the capacity to suck in that particular thing and take that particular solid component upwards. See, liquid absorb hota hai, but this solid component when it is taken upwards is called an adsorption. So processes place the ink spot containing different solid constituent dye on the filter paper. The filter paper is hung with its lower end completely dipped in the solvent. Solid constituent in the ink, that is a solvent flows over the ink spot, and the solid constituent dyes A, B, C and D separate out as shown over here. Okay, so this was about the different types or methods of separation of mixtures. So this ends the chapter elements, mixtures and compounds. Thank you.